Hello friends, welcome back. In the last part we covered division of equations using transpose and apply technique. In this part we will see the general formula for division to equations of any order. It is kind of like similar to the generic formula of for multiplication where you go, if you remember, vertical and cross. So it's pretty much like that but a slightly different variation of it. But overall basic principle remains the same. So let's look at few examples. So here's the first one. So here you would have noticed that it's not like the normal multiplication or division that we have been doing so far. It's slightly different. So the equation dividend we have is 3x squared minus x minus 5 and divisor is this. So the way to do is this. Let's write down the coefficient of the highest power. So in this of the dividend. So in this case it's 3x squared. Now the technique is that okay, so how will you reach this power? How will you achieve this? So on the divisor side you have 3x as the highest power multiplied by, I'm doing it by dots just as to differentiate from the x. So 3x times, let's say, a. So 3x square of dividend has to be achieved by multiplying 3x of divisor, the highest power of divisor, multiplied by something. So what would it be? If we look at this simple division, then what it gives us is just x, right? 3x divided by 3x squared divided by 3x just gives us x. So the first term of quotient that you get is x. So far so good. The next term is minus x of dividend. Now how do you achieve this number? So in the first term of the quotient that you got is x, so it has to be multiplied by the second term of the divisor, so minus 7x, if I say minus 7x because it's a cross multiplication, plus 3x times b because it is a cross multiplication, so it can also be achieved by multiplying 3x into some number which is power of x is 0. So again, if we do, so what are we going to get here? So 3x times b equals to 6x, which in turn gives us b equal to 2. So that's our second term of the quotient. Now we have pretty much exhausted all the terms in the quotient. So now whatever remains, whatever comes up next would only be remainder. Let's look at the next number. So next number in here is minus 5. So how can you get minus 5? So it should be like the multiplication of all the numbers only. So basically it would be minus 5 can be achieved by multiplying plus 2 of the quotient with minus 7 of the divisor. So if I write plus 2 minus into minus 7 gives us minus 14 plus something. So that something gives us 9. So in here the remainder is 9. So it's a slightly different technique, but as you practice more it would be very easy to understand and then apply to any equation. Here you would have also noticed that as compared to the previous video wherein our highest power didn't contain any coefficient, so it was like a kind of like coefficient was assumed to be 1. Of course you can do that technique by adjusting that coefficient, but I left it to this part because this technique automatically covers it. So let's look at another example. Again the same thing. So how do you achieve 16x square is equal to 4x times say a, which gives us a equal to 4x. So the first term of the quotient would be 4x. Then comes the second term, which is of the divisor dividend is 8x. So how do you receive 8x? So 8x is like 4x 4x of the quotient multiplied by 1, let's say. So it is 4x only pretty much, plus 1 multiplied by something, so I call it b, so which in turn gives us b equal to again 4x. It's actually 4x because it's a cross multiplication, so 4x of the divisor multiplied by something which is b, and then this 4x multiplied by the second term of the divisor, which is 1. So that gives us b equal to 1. So now we exhausted all terms of quotient, so that's our quotient. And then comes the last term, which is 1. So 1 equal to what? 1 equal to 1 multiplied by this 1 plus c, let's say. So that gives us c equal to 0. So our remainder in this example would be 0. Let's look at another example. So in here we have divisor which is of quadratic equation, and we have a dividend which is cubic. So let's see. So how do you achieve x cube? Is equal to basically the x square multiplied with something, let's say. So it gives us a equal to just x, right? So our now highest term in the quotient would be x. And let's look at another term of the dividend. So it is 2x square. So 2x square is what? This can be achieved by a couple of things. One, multiplying this minus x, the second term of the divisor, with the highest term of the quotient. So it would be minus x into x plus the highest term of this highest term of the divisor, x square, into something, let's say. So what that gives us is this is x square, so x square will go here, so it will become 3x square divided by, let's write it down actually. So 3x square equal to x square times b. So now it should be clear. Which gives us b equal to 3. So our second term of the quotient is 3. So now we exhausted all the terms of quotient. Now it is boiled down to the remainder. So now the third term in the dividend is 3x. So how can you achieve 3x? So basically 3x can be achieved by number of things, multiplying first the second term of divisor with the x0's coefficient in the quotient, so it's minus 3x, plus this minus 1, the last term of the divisor with the first term of the quotient, so that's another minus x, plus let's say something like c, so let's say, so that what it gives us is that 3 minus 4, that's 4x, and then it will go to 3 on the other side, so it will give us c equal to 7x. So first term of the remainder is 7x. Then we go down to the next term of the dividend, that is 5. So how can we achieve 5? 5 can be achieved by multiplying the divisor's last term with the last term of the quotient, minus 3 plus something like d, so which gives us d equal to 8. So our remainder is, so answer is quotient x plus 3, remainder 7x plus 8. Let's look at another example. So here we are looking at dividend which has highest power of x is x4. So let's do the same thing. So how do you achieve this 12? I will not write down this power of x's anymore, just to make it simpler. So how do you achieve 12? So 12 can be achieved by multiplying this highest power of divisor with the I would write it down 1 because its coefficient is 1 into a, so that gives us a equal to 12. Now x4 divided by x square is x square, so it is nothing but 12 x square. That's the first term of the quotient. Then the next power, next highest power in dividend is minus 3. So how do you achieve minus 3? X cube. So 3x cube can be achieved by multiplying the, in here there is no power of 0, so if I write down, so even if you multiply this 12x square, that is highest power of 12 in the quotient with say 0x, so it will give us 0 actually. So that is, we will not write it down, but other way around it may not be true. So for example, x square, the highest power in here, it can be multiplied by something. So I would write down 1 into say b, and then any other way to achieve x square, no, because it's 0, so it's gone. So that's the only case actually. So that gives us b equal to minus 3. So that will be minus minus 3x then the term for the next coefficient of x is minus 39. So if we write down minus 39, so how can we achieve minus 39? So minus 39 can be achieved by because for x power 0, so leave it, or multiplying this minus 3x quotient with 1, that's number 1. Minus 3x plus some term d, say c, which gives us c equal to 2 minus 36x. So So this will be our first term of the remainder, that is x. Then comes the last term of the dividend, which is minus 12, which is, now if you notice, there is nothing left in the question, so 1 multiplied by 0, because there is no term without any coefficient of x here, so it would be 0 plus something like d, which gives us d equal to minus 12 anyway. So answer is minus 12. Let's look at another example. So again the same principle will apply. So if we write down first term of the dividend, so power of it is 1 equal to highest power of the divisor is 1 multiplied by a, which gives us a equal to 1. So our first term would be x square. The next power of dividend is 3, so 3 is equal to what? The second power of divisor 6 multiplied by x square, so that's 6 plus let's say the next highest power in question would be something of x, so we would say b. This gives us b equal to minus 3. So the next term in the quotient would be minus 3x. The next highest power in the dividend is minus 16. So how can we achieve minus 16x square? So minus 16x square can be achieved by multiplying the highest power of x square with something. So I would say c into 1 plus 6 multiplied by minus 3. So I would say minus 18 plus this x square of quotient multiplied by 1. So I would say plus 1, which gives us what? C equal to 2. Actually minus 17 when it goes on the other side, so it becomes plus 17. So it will give us just 1. So the third term in the quotient would be just 1. Then comes the next term on the dividend, so which is 1. 1 is equal to 1 multiplied by this one, so dividend equation, so 1 plus, let's say d, which gives us d equal to 0. So our remainder is nothing but 0. So in this part we have covered the generic formula for division. I would say you practice with both the transpose and apply and the generic formula of division for equations as well as for numbers of any order and any complexity, and share your feedback. In the next few parts we will look at the factorization of quadratic equations. See you in the next video. Bye for now.